Hey guys, this is Laknara Education. So in this video, we are going to talk about the CPU, the Central Processing Unit, often referred as the brain of every computer. So in this video, we'll explore the functions, components, key specification of CPU that drives a computer's performance. Introduction to the CPU. The CPU is the heart of the computer and it's responsible for executing instructions, processing data, and running software programs. The CPU takes care of everything from calculation to controlling how data moves inside the system. What is the CPU? The CPU is responsible for interpreting and executing instructions. Whether it's performing complex calculation, making logical decisions, or managing data, every task of the computer carries out begins with the CPU. CPU's tasks. To perform a task, the CPU follows a four-step cycle. That is, fetch, decode, execute, and store. First, it fetches an instruction from the memory, then decodes it as it can be understandable by the CPU, and then it executes it, and finally it stores the result back into the memory. This cycle is fundamental to how the CPU works. Measuring the CPU speed. The performance of a CPU is often measured by its clock speed expressed in gigahertz. It tells us how many cycles the CPU can perform per second. A higher clock speed generally means faster processing, but other factors like number of cores, architecture, and cache memory also play important roles in performance. Key components of the CPU. The CPU, or the Central Processing Unit, is the brain of the computer. It's made up of a few important parts that work together to make everything work smoothly. The control unit, or the CU, acts like the manager and directing the flow of information and telling other parts of the CPU what to do. And the arithmetic logical unit, or the ALU, is like the calculator, performing all the math and logical operations like adding numbers or comparing values. Meanwhile, the memory registers are small, super fast storage spaces inside the CPU, holding data that's being worked right now. Together, these components allow the CPU to process instructions, make decisions, and manage memory, enabling the computer to perform tasks quickly and efficiently. Control unit. The control unit is like the manager of the CPU. It makes sure everything inside the CPU happens in the right order. First, it decodes the instructions from the memory to figure out what needs to be done. Then it sends control signals to the part like ALU, registers, and telling them what to do. The CPU also controls read and write operations, deciding when to get data from memory and send data back. Finally, it keeps everything synced by managing the timing of all processes inside the CPU. In simple terms, the CU ensures that all the parts of the CPU work together smoothly and in the right sequence. ALU, or the Arithmetic Logic Unit. The ALU is where all the calculation and logical operations happen inside the computer. Think of it as the calculator of the computer. It performs basic math operations like addition, subtraction, multiplication, and division. For example, when you add numbers or calculate something in a game, the ALU is handling those calculations. Both the ALU also does logical operations. These are used to compare values like and or not. For instance, if the computer needs to check if two conditions are both true, it uses the AND operation. If it is only one needs to be true, it uses the or operation, and if it needs to reverse the condition, it uses the not. The ALU is the key in running any software on the computer. Whether you are playing a game, browsing the internet, or using an app, the ALU is performing necessary calculations and logical operation to make everything work smoothly. Memory registers. Memory registers are small, fast storage area inside the CPU that temporarily hold data, instructions, and memory addresses. These registers are essential because they allow the CPU to access information quickly. There are different types of registers, each with its own job. The first one is the MAR, which is Memory Address Register, holds the address of the memory location the CPU trying to access. It is like the address of a house. It tells the CPU where to find the data it needs. And the second one is the MDR, Memory Data Register, also known as MBR, which is Memory Buffer Register. It holds the actual data that is being read from or written to memory. When the CPU wants to send or receive data, the MDR temporarily holds the data. And the third one is the PC, which is Program Counter. Keeps track of the addresses of the next instructions to be executed. After each instruction is completed, the PC updates to the next one. And the fourth one is the IR, which is the instruction register. It holds the current instruction that CPU is executing. It stores the instruction that has been fetched from the memory and is now being decoded and processed. So these registers work together to help the CPU process instructions and data efficiently, making sure everything happens in the right order at the right time. When we look at the CPU specification, we focus on key factors like number of transistors, number of registers, cache memory, clock speed, and buses. So transistors are tiny switches inside the CPU that help it process tasks. The more transistors, the more powerful CPU. Registers are the small storage spaces that hold data the CPU working with. More registers mean faster processing. Cache memory is super fast storage that keeps frequently used data close to the CPU, speeding up the performance. The clock speed determines how fast the CPU can process instructions. A higher clock speed means faster performance. Buses carries data between parts of the computer. Wider buses can transfer more data at once, making the CPU faster. Together, these specifications help the CPU to handle complex tasks more efficiently.